In the last video, we have gone through the problem of design a circular water tank with flexible base for capacity of 5 lakh liters. And we have gone through the solution, step number 1, where we have used the depth of 4 meter assumed, and then we have gone through the calculation of D using the volume formula, and then once we got this D, then we have gone through the step number 2, where maximum hook tension at the base is calculated, and from that we have also calculated what is the area of steel required, and accordingly if we just provide 16 mm diameter bar, then we can provide the spacing at the 70 mm center to center. Now we'll go ahead. Now we will be going through the next step. So we do have that's step number 3. So in step number 3, what we are going to do, we are going to calculate the thickness of the wall. Okay. So before that, we will be writing what exactly the allowable stress in the tension is. So since there is no grade of the concrete is mentioned in the problem, so we can use M20 grade of concrete. So for M20 grade of the concrete, we have allowable stress in tension. Allowable stress in tension, if we and that is equals to 1.2 Newton per mm square. If you have gone through my earlier videos, earlier recordings, so in that case you might understand that there are different tables we have used, and in that case we have mentioned there. So let us say let T be the thickness of the wall. Let us say it is in mm. Now in the water tank we do have the formula for stress. So for formula of tensile stress, which we already have the tensile stress, but from there we need to calculate thickness. So tensile stress is equal to T max, that is equal to WHD by 2, and that divided by 1000 T plus M minus 1 into 80. So this is in actually Newton per mm square. Now T max we have already calculated in the step number 2. Now this is the empirical formula that you may get in many other books, just like Punmya or Shahankarve. Likewise, in many other books you will get this empirical formula for the calculation of the thickness, where tensile stress is equal to T max, that is nothing but the force, and so stress equals to force divided by area, just like that is there, where 80, this is the 1000 T, it is in mm. If we just consider, then m is the modular ratio, and then 80, it is the area of the steel we have provided, or we are going to provide area of the steel. Now if we just consider, so therefore you have this for tensile stress, we got here allowable tensile stress is 1.2, it is in Newton per mm square. Tmax we already got, Tmax is 260, it is in kilonewton, so you need to convert it in terms of 260 into 10 raised to power 3, we have converted in Newton. So 1002 T plus modular ratio for M20 grade of concrete, it is 13, and that multiplied by now we have provided the steel, that is 16 mm diameter bar at 70 mm center to center. So if we just calculate area of steel required, so if we just consider area of the steel required, which we have already got here, this is 2600. So if we just consider here 2600, okay, so we can provide approximate thickness. If we just calculate now this thing, so we can provide the thickness of around 260 mm. This is going to be around, we can round it up, so that around thickness of 260 mm. So this is the thickness we got. Now once we got the thickness, now the next part would be to calculate area of the steel required for the vertical reinforcement. Now since it is more than 250 mm, we have to use the hoop reinforcement on both the faces. Hoop reinforcement is to be provided on both the faces. So we'll go ahead with the next step. So step number 4 is to calculate vertical reinforcement, area of the vertical reinforcement. So again we are going to provide before that we can say hoop reinforcement shall be provided on both faces Okay. In that case, 16 mm diameter bar, we have already used 16 mm diameter bar. Earlier it was 70 mm center to center. Okay, earlier this was 70 mm center to center. Now we are going to provide it's double. So at let us say 70 multiplied by 2, which is equals to 140 mm center to center on each face. So that is in other direction, on each face on the in the other direction. So now let us go for the step number 5. That is for the vertical reinforcement. Now you can just write down that vertical reinforcement Okay, so for vertical reinforcement, what you can do is to just make sure about the criteria and say 0.1% in case of 350 mm and in our case we want it on the for 260. What is the vertical reinforcement? So vertical reinforcement you may get here if you just interpolate 0.3 minus 0.1 into 260 minus 100 divided by 350. So you will get it around 0.26 percentage. So therefore area of vertical reinforcement that is equals to 0.260 into 1000. So that is 675 mm square. So therefore we got it here 675 mm square. Now area required on each face. So we need to calculate area. So what we are seeing, we got this, suppose this is the wall tank. Okay. So we have provided the hoop reinforcement like this on both the faces. So on both the faces we have provided the hoop reinforcement. Now we need to again calculate the vertical reinforcement. Okay. So vertical reinforcement we are going to calculate not on this face as well as this face. On both the faces we need to calculate on. We got the overall 675 mm square as the area of the steel. So therefore area required on each face. Area required on each face will be half of that, so 675 divided by 2, and that is equals to around 338 mm square. So in a similar way as we have seen in the earlier cases, how to get the spacing. So let us use 10 mm diameter bar. Since hoop reinforcement, these are actually called as the hoop reinforcement. So if we use 10 mm diameter bar, so the spacing required, we can simply get the spacing as we got the earlier one. So the spacing would be around 220 mm, center to center on each face. So this is not just nothing but for the spacing. Now what we need to do is to calculate. Here we got the 10 mm diameter bar at 220 mm center to center on each face. Now we will be going to the next one, that is to the main reinforcement at the different depth also that we can calculate. So let us calculate main reinforcement at the depth of 3 meters from the top. So step number 6. So before moving forward, we'll just recap what we have seen earlier. This is our problem: design a circular water tank with flexible base for capacity of 5 lakh liters. Now we have first of all assumed the depth, and then we have calculated the diameter from the formula of volume equals to area into height. And here we got the maximum hoop tension. Once we got the maximum hoop tension, we will get the area of steel required, and then we get the spacing using this formula: area of 1 bar divided by total area, and that multiplied by 1000 because we are considering it for 1 meter. And then next we have to consider that we need to calculate the thickness. How to get the thickness? If we just using the M20 grade of the concrete, allowable stress in the tension, that is 1.2 Newton per mm square. How we'll get it? So you can just go through my earlier videos. You will get the different table, and from there tensile stress equals to this empirical formula. There is nothing but the force divided by area, and this is the empirical formula from where we'll get the thickness here. And in the next step, what we have assumed that hoop reinforcement, since it is greater than 250 mm, we have to provide on both the faces, and that we can consider since we have to provide it on both the faces. So whatever area we got, okay, earlier we have considered, let us have that is not more than 250 mm. So we consider that it may be provided at the 70 on center to center, but now if it is on both the faces, so we have just doubled it. The spacing we have doubled it. Okay, we have just curtailed that particular AST, and that is the reason this is 70 multiplied by 2, 140 mm on each face. This is what we have considered. And now next was the step number 5, where we have just provided vertical reinforcement. How to get the vertical reinforcement? We have just considered, say, it will vary from 0.1% to 0.3%, okay, for the thickness of 100 mm to 350 mm. So this is what we got, 0.26%. And then area of vertical reinforcement we can get just like the percentage multiplied by this thickness. This is the 260 your thickness, and this 1 meter per meter we are just calculating, and we got the area required on each face. So that is will be half of this two. Again, just we have considered the earlier case. Now here we need to use 10 mm diameter bar, and spacing as we have gone through, that area of 1 bar, that is nothing but the, say, by 4 into 10 square and divided by 338 and multiplied by 1000. So this is what you will get, around 220. And in the next step, we will be calculating main reinforcement at the different depth, as well as the reinforcement at the base slab. Okay, that we will be doing in the next video. Thank you.